Okay, so we are now in chapter 18, um, where we study cross-tabulated counts. Actually, in this chapter, we are doing something new. We are talking about, in fact, two different random variables which are categorical. That means qualitative. Okay, so it's not continuous data that we are working with. It's categorical or qualitative data. Okay, that means like gender, ethnicity, disease status, smoking status, which do not take numerical values. And then we will consider two such variables, and we are going to see, are they really associated with each other, or are they not connected at all? Things like that, which is really important in health related studies. Okay, all right. So this is what chapter 18 is about. So it's looking for associations between categorical, which are also called qualitative variables. Okay, so let's go to the outline for the chapter. So we are going to talk a little bit about types of samples, and which are like in this section, and then chi-square test of association. Now, test for trend, like actually I should write in here 18.4 to 18.6, not covered, not included in test. I'll just put like that. Since this is like a beginning biostat class, I'm not going to go into that in this material, but I'm going to leave the slides in here so that if you like, you can even read through them and then get a good idea. But certainly, if you do a higher level biostat class, you will learn these topics as well. Okay, so we are going to cover only the first three topics in this presentation, and that's pretty much what is needed as far as the tests are concerned for this course. Okay, from chapter 18. So it's the top three sections. Okay, so now first of all, types of samples. Now we have considered, so far, when you think about qualitative variable or categorical variables, we have pretty much considered binomial variables, yes or no situations, right? Either a person is a smoker or not, male or female. So always, we consider situations where there are two possible outcomes. But see, of course, you can get so many different qualitative or categorical variables which has more than two outcomes, right? Think about ethnicity. Ethnicity has more than two possible outcomes, right? Even a disease status, you can say no disease at all, normal but serious. So there are like three levels in that case. So like that, there are lots of situations where we have several outcomes possible, more than two. Okay, all right, so let's go in here. So now types of samples. First of all, now see, when you carry out studies in public health or in medicine, there are like three different types or three different sampling types that you can break down into. These are the three main ones, so let me go over that. Now, first one is a naturalistic samples. That means you do not make any designing at all. What you do is you just take a bunch of people, and then you will look to see, okay, if you are interested in two different categorical variables, you will record the exact values that these people have. Like an example is, you can just take a sample of 500 babies, and then you can classify each baby according to the birth weight and the mother's smoking status. Because people say that if a mother smokes during pregnancy, that could have a negative effect on birth weight. Okay, so you are going to take a bunch of babies, 500 I said here, and then you are going to record these two different variables. Actually, birth weight status, I sort of categorized it as low, normal, and high, and then the other one is smoking status of the mother, which are both categorical. Now, see, in addition to these two being categorical, when we talk about two variables, think even outside of statistics, think even in any subject that you do, you have a y and an x, right? See, even when you plot data. Now, y is considered to be dependent on x. So we need to sort of carry that same idea here. So we need to sort of ask, okay, what is going to depend on what? Okay, so in here, the smoking status of the mother is going to influence the birth weight. So which means birth weight is going to be Y. That is depending on whether the mother smokes or not. So this is the Y, and mother's smoking status is X. So now, of course, there are different terms that are used here. So the Y is also called the response variable, dependent variable. Now in biostatistics, public health, that is called the outcome. Okay. Likewise, the X in here it is the mother smoking status. Now that is called the explanatory variable. So now this is the variable which is influencing the dependent variable, and sometimes it's called the input variable. In biostatistics and public health, almost always it is called the exposure, because if you are exposed to something, an outcome will occur. Okay, so this is the X influences the Y. Okay, exposure influences outcome. All right, so so keep in mind always there are these, whenever we study two variables, we need to look to see, okay, what is the outcome, what is the exposure. Okay, so that is okay, this is first type. Second one is of course having some design, that is like, see, purposive cohort samples. Purposive definitely means that there is a purpose. So it is like a cohort sample, means you will gather a cohort of people or items or anything which has a certain characteristic. Okay, and that characteristic is the explanatory factor, which is the exposure. That means you are looking for a certain, some characteristic which is evident in a bunch of people, and all the people who are in the sample, okay, should have that outcome or the explanatory factor. Like an example, 100 babies are chosen, um, whose mothers have smoked during pregnancy. I think there should be yeah. So in here, this is a cohort of babies. Now, what is the special explanatory factor in here? Mothers have smoked. Okay, so then now you can study these babies and see, okay, what will happen to these babies later on. Okay, in addition to the low birth weight, would there be any other stuff that could be detrimental because the mothers have smoked during pregnancy? So it's a cohort of babies, and you will keep on watching their health status as they as they keep growing. Okay, now that is the second type of sample. The third one is a case control sample. Now in here, what you are doing is, okay, you are looking at an outcome. You are choosing people or items based on an outcome. Okay, and then so you will choose that outcome. Now like in here, the birth weight status. Okay, like whether babies have low birth weight or normal birth weight. Okay, so you will collect 100 babies, but you will have the cases who are of low birth weight, and then of course the controls who are normal. Okay, and then okay, we will go back and see, okay, what was really the cause for this. Okay, all right then. So these are the three different types of sampling that occurs most commonly in biostatistics. Okay, so now in the next three slides there are three examples. See, so that's the second one, and the third one. You may go over them. I'm not going to go over them, but because it's pretty self-explanatory. But you may go over them. Okay, so that you will understand applications of these different types of sampling in public health. Okay, all right. Let's go to this slide now to talk about how the statistics works. So now, okay, in the naturalistic and cohort samples, let's first of all deal with the first two types of sampling. Now, Usually you will have the data in a table form. So that is why, in fact, this chapter's title, a cross tabulation. So here's a cross tabulated. See, it's cross tabulated according to two factors. Now you have the outcome and the exposure. Now typically the explanatory variable, okay, which is the exposure, okay, will be placed in along the rows. Okay, so in here exposure is education level. Now depending on what you are exposed to within course, okay, are you going to smoke or not? Okay, so smoking status is going to be the outcome. Okay, so outcome is in columns typically, and the exposure is in rows. Okay, so that is typically what the convention is. Okay, all right. So in other words, y is in columns, right? And x is in rows. So that's what I have written in here. And then if you want to see, once you do a study, if you want to be a little bit descriptive, it's a good idea to sort of, get the, let's see, if you go in here, you can get the column totals and the row totals, and then based on these numbers you can do a histogram describing the education status, and then using these two you can do another histogram describing the smoking status. You can sort of compare then how many are smoking versus how many are not. So that's what these two histograms are telling. um, and then um, and then let's go. So that is just a descriptive way, descriptive method to see how the data is looking. It seems as if, let's see, so this is smoking. Most are, let's see, one stands for what? They say it in here. So most are smoking, see. So this will be, most are smoking, high number are smoking compared to not smoking. And then the education level is highest in category 4. And if you go back in here, category 4 is um, undergraduate degree, right? Undergraduate degree. Okay, so let's go to, so let me, now let's think in terms of that table in here. Now these are stuff that are important when you do the statistics. Now there's something called a row percent. Now row percents are used in cohort and naturalistic samples, and it describes the prevalence. Remember prevalence, that means the proportion that a disease occurs. Now so row percents are used for that. Like for example, now if I go back in here, so to get the raw percents for smoking, it will be like 12 divided by 50. So, and then you can calculate the raw percents for each different education level. So this is the exposure. So for each exposure level, you can calculate the prevalence. So 12 divided by 50 would be the prevalence if you have a high school education. 5 divided by 57 is the prevalence for smoking if you have a graduate degree. So it looks like as if you have a graduate degree, you may not be inclined to be smoking as much as perhaps if you just have an undergraduate degree, right? Okay, all right. So let's go here. So that's about row percents. And then also column percents you can calculate the same way. Let me go back here. So column percents will be like you will have yeah, nine column percents will be like 5 over 94 would be the uh, would yeah, so like 5 over 94 would be the proportion of graduates who are smoking. So like that you can calculate that. Sometimes of course for cohort studies and for natural samples, row percents are meaningful, than column percents. Okay, so that's let's go to this slide in here. um, and column percents are usefully in case control samples. Okay, all right, let's go into the next one. Now, so now how do you calculate the incidence and the prevalence? Okay, remember we talked about this. These are like the raw percents. So now actually, in this situation, see, remember exposures are in the rows. So there are how many of them? There are R levels. So this is like the general notation, right? Now, in the previous example we had 5 education levels, so R was 5. Okay, here for the general situation, we will have R different groups, and then the outcome, of course, has only two, smoking or not. And then you can calculate the incidence or the prevalence by the cell count divided by the total. So it will be like A1 over N1, A2 over N2, and so forth. So if I am to introduce this I suffix to denote a group I, so for the group I, to get the incidence will be AI divided by NI. Okay, so that's pretty much what this formula is telling. I mean, of course, this is quite obvious, like with numerical example before, we understood how to get this. Okay, so so this is the formula. If you have a 2 by 2 table, and if your exposure levels are in the rows, how you can calculate incidence or prevalence. Okay, all right, let's go to the next one. So now here they have done it. They have calculated the PIs. So 12 over 50 and so forth. So you get these numbers. These are the prevalences for each education level. Look, the prevalence of smoking for graduate degrees, if you have a graduate degree, is 0.08 compared to if you have only a high school. So it looks like as if high schools are really, opting to smoke much more than than those who have a grad level degree. Okay. So smoking seem to have, you always start with the high school. So when you're in high school, you tend to smoke more. But then you keep on, maybe you give up that habit as you grow older. Okay. So now, now relative risk. Now relative risk is something where you compare different exposure levels. Okay. So what you do is, okay, if you want to find the relative risk for the ith group or the ith level, you will divide the prevalence by the prevalence which has the least exposed, which is here this one is the least exposed group. Least exposed means the one which has the lowest frequency. Okay, so if you go back in here, so you need to look up the totals. So in these categories, which has the lowest frequency? Actually the high school graduates. So this is the one which is least exposed. Okay, exposure means, these are the exposure levels. So that level or that group is least exposed, because see, that's the lowest number. Okay, so in other words, if you want to go, let me go to this slide. If you want to find the relative risk for each group, you have to compare with the high school. Okay, so that's what has been done in here. So now you need to divide to get the relative risk. You need to divide each of these by this, because this is the one with the least exposed. So this is like the reference group, and then you will get this. And notice when you divide this by this, you will get 1. And then it has been calculated here. You can see how much lower the graduate degree relative risk is for smoking compared to even associate degree here, right? Okay, so now that was relative risk. Now there's another measure that we look to, to compare associations between variables, odds ratios. Now this is really important, even though the book says optional. This is very important, so I'm going to go over this. But certainly when you do a higher level class, you will use this quite often, and even in research articles, odds ratios are a very common measure that is being used. So now, first of all, to define odds, we need to first define odds. odds of an event, like odds of smoking or something, is equal to the number of successes divided by the number of failures. Okay, so this is for each group. Odds of an event. Event is a success. Now in the previous example it was smoking. Now once you find the odds for a particular group, like in the previous example it was the education level, you can find the odds ratios. You can compare different education levels. Okay, so then all you do is you take the ratio of the two different odds and then you will have this. Okay, now typically odds ratios are used for 2 by 2. That means when R is 2. Okay, so now let's see how that works when you go to yeah, now see in here they have done odds ratios for the education level, and then so they have used the reference group to be the first one. So all they are doing is they are comparing each of these with the high school. So you first find the odds and then you divide each of these by that, and then you get this. So when you divide this by this, you get this by that, you get that. Okay, like that. And then see, you can see then you can compare each different level with the reference group, which is the high school education level. Okay, now of course, see, when you have all these odds ratios, you cannot make a lot of sense about it. Of course, if you are going to pay attention only to one particular level and you're comparing it with the other group, which is high school in here, it is okay. But to me, odds ratios make a lot of sense if you have only 2 by 2. Okay, so let's see in here. Now I think I missed something. Let's see. Yeah, okay. I cannot. Yeah, now let's see. So you have odds ratios done for um, um, each of these different education levels, comparing it with the high school. And then also remember, if odds ratio is 1, then that means there is no difference between the two different levels as far as smoking goes. Okay, now of course this one makes no sense because you are comparing high school with high school itself. But now if you look at associate degree versus high school, you have odds ratio of 0.85. Now this is closer to 1 than, for example, 0.3 here. So what you can sort of conclude from here is that as far as smoking goes, the association between high school and associate degree is much more than with a graduate degree. Okay, there is some association between high school, between education level and smoking, but that association varies based on the education level. The association difference is much more between graduate degree and high school than compared with associate degree and high school, if you look at the odds ratios. Okay, now of course there are hypothesis testing, confidence interval calculations, just like what we did for means and stuff, for odds ratios. Actually, in the later slides in this presentation, those are mentioned, but I won't hold you responsible. But if you are curious, you can certainly read through these slides. But later on, when you do a higher level course, I'm definite that you will come across those. Okay, but for now, just keep in mind odds ratio is close to 1 means the association, there is no association. But if odds ratio is away from 1, then there is an association between the two variables. Okay, all right. Okay, so here's another example. In here, the treatment. This medicine, I really cannot pronounce it. This is a treatment for you know, upper respiratory symptoms in children. Okay, so this data is coming from you know, comparing the treatment versus placebo. That means placebo means no drug at all, right? And then you're looking to see, okay, how are the symptoms, and then based on, of course, the parental assessment. And then you can see that, you know, these are the numbers. So some children who were given the drug had mild symptoms. That means 153 of them, and so forth. Okay, so this is the raw data. And then once you can calculate the row percents. Remember, we talked about row percents. So to get the row percents, let me go back in here. Now to get the row percent for those who were given the drug, and then to look for each of these different categories, you will have 153 divided by 329, 128 divided by 329, and so forth. Okay, so let's look at the row percents in the, so these are the row percents, and then you can sort of, from the row percents, you can sort of see that, okay, it looks to me as if, actually, look, if you think about the children who were given the drug, they are in the severe category more than those who were given the placebo, right? It's interesting. It seems as if the drug performed worse in one way, right? So look at it carefully. So just because you give a drug, that does not mean that, you know, that will give good good relief. So that's in fact why clinical trials are conducted, right? Okay, so now let me go back in here. See here, you have the exposure have 2 levels and the outcome are 3, right? Now I think I mentioned that, you know, odds ratios are really meaningful, or at least you can make sense if you have like a 2 by 2. I mean, or even if you have more than 2 levels. To make sense, you know, you almost always have to compare just 2 different levels. Okay, so what if you have several levels? You need to, and in fact, odds ratios, you cannot have a it is like a pairwise comparison. Okay, even if you do a hypothesis test or a confidence interval calculation, you can do odds ratio only for to compare 2 different levels. Okay, but see, now in here you have 3 different outcome levels. So let's look in here. So how will you sort of generalize the idea? Now that is done by chi-square test of association. So if you have more than 2 levels, this makes more sense. You will form the hypothesis of no association between the 2 variables under consideration. The 2 variables mean the exposure and the outcome. In the previous example, the drug versus placebo and the symptoms, right? Is there association? If you give the drug, will the symptoms be mild? So that is what we are after. Now, null hypothesis is saying there is no association. Both the drug and the placebo have similar effects. Okay. Now, HA says there is an association. Association means either the drug or the placebo will have, different, like there may be more severe cases in among children who have taken the drug um, or the placebo. Okay, all right. So now to do this test, you have to form a test statistic. Remember, we know from our previous work, always to do a hypothesis test, you need to form a test statistic. Okay. Now the test statistic in here is called a chi-square. Now chi-square itself is a probability distribution. Okay. Now any random variable which has that shape is called a chi-square test statistic. Okay, chi-square test statistic. Now the test statistic which goes with this hypothesis has a chi-square distribution, and then how do you find that? Using this formula. Now this OI means how many do you observe for each cell in that table. Okay, OIs are the observed count. EI are the expected count. How many do you expect in each cell if H null is true? And how do you calculate expected value? Right here. You will take the row total times the column total and divide by the table total. So the expected will be equal to this if H null is true. So in other words, if H null is true, the observed should be close to EI, right? Expected. Observed should be equal to expected. And then if that happens, this will be pretty close to this. Then this entire sum, this sigma means summation, right? You are adding over all the cells. Okay. Then if each of these is very small, the whole thing will be very small. So a small chi-square means a small chi-square will favor H null, a large chi-square will favor HA. Okay. So just like in the previous work we did, based on the chi-square, we can calculate the p-value, and a small p will lead us to reject H null, just like what we did previously. Okay. All right then. Now also remember chi-square. In the next slide we will see how a chi-square looks like. It is based on the degrees of freedom, just like students T, and then the shape changes slightly. Okay. All right, let's go in here. Yeah, not the next slide. The chi-square will come pretty soon. Okay. All right, so now to calculate, what is this? Okay. Yeah, so now I think this has the raw data. These are the observed values, 12, 38, and so forth. Okay. Now in the next slide we can see the calculated, we can see the expected frequencies. Counts and frequencies are the same. Remember the formula is row total times column total divided by table total. So like for example, how did you get this? Row total is 50, column total is 94. So 50 times 94 divided by the table total, which is 585, will give you this. See, that's what they have shown in here. Okay. So you can calculate the expected value for each cell. Then you have the observed. These are the EIs. The observed, which are OIs, were in the previous table. You take the difference. So let's see. So now when you spell out that sigma notation thing, the sigma, you have to sum over all the cells. This is the first cell, this is the second cell, and so forth. So altogether, if I go back in here, how many cells are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Typically, number of rows in a table would be number of cells in a table will be number of rows times the number of columns. So there are 5 here, times 2 will give you 10. Okay, so you can see that there will be 10 terms when how many are you adding over? 10 of them. And then once you simplify that, you will get that. And then how do you get the degrees of freedom? It is R minus 1 times C minus 1. R is number of rows. Maybe I'll write it in here. R stands for number of rows, and C is equal to number of columns. Okay, number of columns. So C stands for number of columns. Okay, so 5 minus 1 times 2 minus 1 give you 4. And then and then you found the chi-square to be the whole chi-square statistic to be 13.20. Let me show you right back in here. 13.20. Degrees of freedom is 4. So how do you find the p-value? So let's go in here. Now see, the tables are there. You will find the tables in table E in your book. So that the values are just like in the student T, it's based on the degrees of freedom, and then the right tail probabilities. Okay, right tail probabilities are given on top, and then the chi-square value is given in here. So for example, now see 13.20. By this arrow should have gone somewhere here. So the p value. Can I move it? The 13.20 is somewhere close to here. And then the p-value will be, so p-value for this statistic will be a little bit, actually it's so this time it's a little bit smaller than 0.01. So 13.20 should be somewhere here, right? So p is between 0.025 and 0.01, and of course it is much closer to 0.01. So that's what is mentioned in here. This arrow should have come here. Anyway, it's not easy for me to bring it over here, but remember this is somewhere close to here. Okay, so here's the chi-square shape. Chi-square is not symmetric. It has a mound like a little bit to the left. Okay, so now actually when you mark, if you go back to that table in here, see, look, you have 11.14, the right probability is 0.025, so that's what I have meant, that's what they have put in here. So for 11.14, the right tail is 0.025, for 13.28, 0.01, and the value that we got, chi-square statistic 13.20, should be somewhere here. Okay, so the p-value will be somewhere between 0.025, but will be very close to 0.01. So it's safe for us to say that, okay, p is pretty close to 0.01, which means you reject H null. Remember, small p means you reject H null and you accept HA, which means you conclude that there is an association between the education level and the smoking status. Okay, even from these we can figure it out, and the test of hypothesis really confirms it. Okay, so in fact you can find the chi-square by computer using Minitab, or even the program given in the book, or Excel also gives that. So there are lots of ways that you can calculate the p-value for a chi-square. Just like standard normal or student t, chi-square is also a very common distribution, so you can find the values, p-values for that. Okay. Now from this point on, I'm not holding you responsible, so maybe I'll include a new slide. Okay, so this is the end of course material, right? From this PT. Okay, but see, actually the remaining slides are pretty informative. So if you are inclined to read even after this course, it would be great. And then of course if you do a higher level course, definitely you will come across the topics that are discussed in the slides, in the remaining slides. Okay, so this is the end for chapter 8 as far as this course is concerned. Okay, thank you.